I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 13th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see remnants of a gale fading out southeast of New Zealand, still with seas in the 30 to 31 foot range, aimed pretty well to the northeast, and swell is in the water from it, radiating to the northeast. Also, a pretty decent system is trying to build under Tasmania here with, what is that, about 38-foot seas? We'll see whether it actually survives the journey, though, under New Zealand. Then remnants of a gale previously in the far southeast Pacific are fading out, approaching Patagonia. All right, let's get into the details. As usual, we're going to start out looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough that is a push in the southern branch of the jet to the north, just like there. What that helps to do is create a clockwise flow aloft, and that's the hallmark of low pressure. It also manifests itself down at the surface, and if the low pressure is strong enough, it generates winds. If the winds are strong enough, they generate seas. If the seas are large enough or high enough, as they radiate away from the fetch area, they turn into swell, and swell, if it's large enough and has enough period, produces surf at your beach. But it is a long way from here to California or to Hawaii. So all the real focus here is it's got to be pretty intense. All right, so we're looking at a trough here, but it is a very weak trough with winds, 60 knots or something. That's not enough to get the machine turned on to really get all the parameters that we need to produce swell. So we suspect there is no support for gale development here. A broad kind of trough-like structure, though, is traversing almost the greater part of the South Pacific Ocean. The ice line, about 60 or 61 south, right down around here in the Southwest Pacific, maybe a little bit further south. But the jet this time of year needs to be pretty far to the north to get, open, to get exposure on ice-free waters to then set up the ability to make swell. All right, so that is Sunday night. We'll go into Monday. We see, if anything, it looks like the jet's falling south here. Now, look at this. This is a pretty good trough developing south of Tasmania here with 130-knot winds. We know there's a gale in that area. That's supposed to push under New Zealand as we get into Tuesday. But notice the trough kind of fades. It turns into this zonal flow, sort of a flat west to east type thing. And that doesn't really get what you need. You need the winds pushing, like ridging south and then pushing to the north, and that's what gets the upper level machine flowing to produce swell. See a little bit of that here as we get into Wednesday under New Zealand. And yes, there is a trough and there's some winds, 140 knots, maybe supporting gale development there. And there you go. That's a more classic sort of pattern there. Thursday night into Friday, maybe some hope there. And then look at this big ridge pushing to the south. When you get this split flow and the southern branch diving to the south, what you get is high pressure in between. High pressure does nothing for producing swell. That pattern looks to take over the South Pacific as we get into Saturday. A little bit of a trough here, though, on the leading edge of this ridge on Sunday. We're almost a week out, and that looks to be about it, 180 hours out. The jet's running right along the ice line here, if not dipping south of it. Maybe something in the southeast Pacific, but that's kind of it. All right, let's go take a look down at the surface. Surface level pressure and surface level winds. And here we go. Remnants of the gale that was under New Zealand fading out, 30-foot seas. Another gale developing off Patagonia, 35. Oh, did I say 30-foot seas? No, 30-knot winds. 35-knot winds over here, doing nothing out of the swell window. Cut off for the Southern California is about 117 west right there. All that's to the east of that. And this under Tasmania just coming into the picture. There's some fetch as we get into Monday. Broad, kind of disorganized, a little bit under New Zealand. You want to, well, there's 45-knot winds, but falling south and not aimed right, and then a broad disorganized area of, we'll say 30, well, there's 45 knot winds as we get into midday Tuesday. And there we go. Finally, something that kind of looks interesting Tuesday night. A little dot, that whitish dot there, is 55 knot winds, but over a tiny area and quickly gone, 50 knot winds. Maybe something to result from that as the system pushes off to the east. We're into Thursday now. Everything sort of fades out. You really need 40 to 45 knot winds over a pretty good area for at least 2 days to get decent swell. We're into Saturday, still nothing. There's a gale trying to organize in the central South Pacific on Saturday. Oh, look at that. And 50 knot winds pushing up from the south. Let's see. Oh, there we go. As we get into, but again, look at that. It's a week out. That's Saturday night, almost Sunday. Quickly moving out of the California swell window as we get into Sunday night. Another broad system forecast, but again, look where the fetch is. The ice line's right around here. Don't know if it's going to get, oops, and that was the end of that. So don't know, and it's a week out, so who knows? We'll see. Let's go take a look at the wave models and see the effect of these winds on the ocean surface. But before we do that, we're going to go back to Monday of last week. So was that 6 days ago or so? Little gale tried to pass under New Zealand, produced 30, 32-foot seas over a tiny area, quickly faded out. That is not what we're really looking for. It was this system on Friday morning that developed south of Tasmania with 44-foot seas. Also notice there's this little thing here. Let's go back a little bit. So this gale formed right on the hairy edge. The swell cutoff is like 117 west for Southern California. So we did get some 32, 35 foot going to 38-foot seas, barely in the California swell window. Maybe some south angled swell about a week out, so that'd be Friday the 18th of September. We'll keep an eye on that. But the main event we're looking at is this one that developed Friday under Tasmania and then pushed under New Zealand with 43-foot seas Friday night, continuing with 45-foot seas on Saturday morning. That's actually a little bit better than what the models had suggested even 24 hours earlier. And then pushed pretty cleanly into the Southwest Pacific with 38-foot seas on Saturday night, and then fading while tracking east. And this is where we are right now. So a pretty decent amount of swell. Now the downside is, we'll just run through this gale, it's pretty much running flat west-east, not pushing off to the northeast. The fetch itself in the gale was aimed off to the northeast, but it's the track of the storm itself that's really where the momentum comes from. So most energy tracking this way, not so much up this way. Still, some swell is expected to result. All right, let's go take a look at the future now. Here we are today, 18Z Sunday. We'll move off. That system fades out of the picture. The next system tries to organize under New Zealand, but just doesn't really do it. A little bit of a gale results, small footprint, and moving mainly off to the east with, well, I saw peak seas right around here, 41 foot over a tiny area. Yeah, some small background swell, and most of that's all in the shadow of Tahiti relative to California. And with this west-east track relative to Hawaii doesn't do a whole lot either, especially Hawaii. The prime thing you want for Hawaii is a system that takes a track here and then creeps up the east coast of New Zealand, pushing energy, Tahiti's there, up the other side of Tahiti, also at Hawaii, and also at the U.S. West Coast. But we're not seeing that. All right, so we're into, Friday of this week? Nothing. Saturday, then we get this little system in the far southeast Pacific, but again, it's suffering the same deal, almost falling southeast. Yeah, pretty strong. 44-foot seas, but not aimed well to the north at all. And then another system, we saw it, most of the energy was over, this is the Ross Ice Shelf right in here, and most of the energy not making it north of there, and also it's a week out, so don't believe the models. But we'll keep watching both these systems. Maybe something will result. And then let's take a quick look up north. The good news is you see there's actually something other than deeper shades of blue over the North Pacific. But what we're not seeing is anything in the even 20-foot range, which would be, a step above yellow. Maybe a tiny area, but I mean, you got to have something fairly substantial. Yes, it looks like maybe some wind swell from this system, if it develops on Monday, Tuesday, could evolve for Hawaii. Then also this other kind of weird cutoff low might get some wind swell into California on, it develops Wednesday, so probably like Thursday swell would arrive. And then there's been hints of stuff up in here, but they're on the model, then they disappear, and, it's like the model overhypes it. Then we got one of these over the North Dateline region on Sunday, theoretically with 24-foot seas, but now we're a week out. Same fate. I don't believe the model's more than 3 days out, 4 days maybe. So this is definitely a reach. Probably the next run of the model, it won't even be there, but who knows? We'll keep our eyes on it. But just the way things are going with this La Nina kind of pattern set up, the expectation is the North Pacific is not going to start out strong. It is not going to start out early. It'll be a late start. It'll be a faltering sort of half start, half stop kind of thing. So probably not until late September, early October, something like that. But we'll keep our eyes on it. It's always nice to be surprised. So then we go looking for wind swell, and typically what you need for wind swell is massive high pressure in here, and that happens early, the springtime, early summer. You get later into fall, high pressure starts falling apart. Here we go. A week, was it like 1,000 millibar low? Not really particularly strong. Taking over, no fetch along the California coast as we get into Monday, no fetch relative to Hawaii. And all this fetch aimed north, maybe Vancouver Island, that's all south winds there. But we'll see as this system sort of spins up off of, we'll say Washington, British Columbia, maybe some energy wrapping around the back here. There we go. And maybe at Hawaii, too, that's 30-knot winds. Maybe something to result. This is on Tuesday night into Wednesday, and then the system fades out. But it's really close off the coast, 20-25-knot winds. Maybe some wind swell for California. No fetch for Hawaii. We can keep our eyes on this as we spin through. Nothing. Also, maybe a chance for some weather up here in Washington and extreme northern California. We're into Friday. Nothing. No fetch of interest. And then all of a sudden, as we get into Saturday, high pressure starts to appear to want to get some footing in the Pacific, and as expected, when that happens, the gradient fires up off the Cape Mendocino, North California, starting at north winds at 20-25 knots. There you go. Solid fetch by Sunday morning. That would suggest wind swell down into Central California to Point Conception. And spotty easterly trades building. You really want to see it consistent out here east of Hawaii, but maybe some minimal east wind swell. Then we're into Sunday night. Again, 25, 30, almost 35 knot north winds. But again, a week out. Hard to say if that's going to happen, but we'd say if there's a chance for wind swell, it'll be late next weekend, 7 days from now. Then precip, we're looking for precip, anything to, one, wash the air clean in California, choking on forest fires, and even more importantly, let's deal with the source of the smoke and get some of the forest fires knocked out in Oregon and Northern California. So here is the low. Thank goodness there is a low off the coast. And as we get into maybe Tuesday night and Wednesday, little bits of precip along the Oregon coast, but probably not enough. And then it sort of teases into Thursday. And then finally, as we get into Thursday night, perhaps, again, there's a bit of a reach for the models, but perhaps a bit of rainfall into Oregon. That would be good for that area. And Cape Mendocino at best, but nothing down south. Where we really need a soaking, unfortunately, we think that is going to be the situation this year. Is most of the weather will be shunted off to the north. High pressure in control as we get into winter, driven by La Nina. So that'll push all weather systems to the north. And typically central and even up into mid-northern California tend to be pretty high during those. Pretty high and dry during those time periods. Silly to do it, but we'll look for snowfall. This is Squaw Valley. Virtually nothing forecast. More importantly, we're looking for maybe a drop in temperatures. We do see, so the red is liquid precipitation. The gray is sort of, we'll call it slush, like that 34.5 degree down to 32 degree temperature range where you can get, sort of a mix. And then white, the right of the lower border of the white here is the freezing line. We got a new version of this chart that we're working on too. So, but anyway, we do see that the freezing level comes down to about, what is that, 11,000 feet roughly on the 18th, about midday. So maybe the first, in association with that low that we saw off Cape Mendocino. So maybe the first little hints of fall, perhaps. Then last week we gave you a little teaser of a product we've been working on. So if you go to our snow page, this is it. You click snow right up here at the top. You'll land on this page. You scroll down. There's a variety of models for tracking snow. But buried in this, we've added a new column, temperature level. So this is for like in the summer if you're backpacking, or if you're doing backcountry skiing or backcountry in the winter sort of type adventure, looking at temperature profile at elevation. This whole column, every resort we got now has an icon, and here's what you get when you click on it. And again, this is Mount Whitney, same we showed last week, but this is now live. This was as of the 12Z model run today. And we'll scroll down here just a little bit so you can see this. So 5A. So this is the starting time's up in the upper right, and then it's every 24 hours, but the date underneath it is every 3 hours. And here's elevation for Mount Whitney. This is the base of Mount Whitney here. It's actually over on the east side of the Sierra down there. I don't know. It's not Independence, but the town just there near Whitney Portal. And then you can't see it, but the other dotted line is buried up here. And that's the summit of Whitney. It's actually above the level of the chart. But you can see temperature at, let's say you're at, 6,500 feet. 75 degrees during the day, 60 degrees at night, 70, 60. You get the idea. We get into that cold spot, high temperature during the day, maybe 60 degrees in the blue there. What's that? Probably 50, 55 at night. So the idea is, depending on what elevation you are and where you are, you can get a sense of temperature. The red line is the freezing line. It's way up here, right? But you get an idea if you're and if you're skiing especially, this is real helpful. And we have that on that other chart that we just showed too, but this is a little bit more detailed. So you can see, well, if it's going to be warm, how warm is it going to be, and when's the freeze line going to come, and all that sort of stuff. So good for planning summer trips, but also winter trips. So add this to your arsenal. All right, and let's get into the meat of it now, the long-term outlook. What's going on with MJO, the Madden-Julian Oscillation, and of course, El Nino or La Nina. As usual, we like to look for the presence of the active phase of the MJO. The active phase of the MJO is what feeds energy to the jet stream, and when you feed energy to the jet stream, that then creates troughs, and troughs help feed the formation of gales, and gales generate winds and seas, which ultimately result in surf. And also the same holds true for generating snow and rainfall. All right, so and the MJO, Madden-Julian Oscillation, 2 phases, active and inactive. It's the active phase we're looking for. The MJO traverses the planet going from west to east on the equator. And what we're looking for is the active phase moving across the Pacific. That's when you get energy transport to the jet stream and all the magic starts happening. The active phase of the MJO acts like a low-pressure system moving across the Pacific, and of course low pressure is good for generating swell. The inactive phase is like high pressure, and that kind of stomps everything down and literally supports high-pressure development over the Pacific Basin. All right, so West Pacific here, East Pacific here, equator here. Kelvin wave generation area from 5 north to 5 south in the far West Pacific, about 135 east, out to the date line, just a little bit past, about 170 west. Draw a box in your mind right here. That is New Guinea there. The date line is right there. So this is the area that when the active phase moves over it, You really get the energy transfer into the jet stream, and you can also get what's known as a Kelvin wave because the active phase acts like low pressure. It stomps on trades, can actually reverse them, and then take warm water in this area and start pushing it off to the east. If you get successive Kelvin waves, that can help kick off El Nino. All right, so what we're looking at, this is data from the TAO buoy array, series of buoys strung across the equator. We're looking at the arrows, 5-day average winds, not real-time hourly like the NOAA buoys, but gives you a rough idea of what's going on over a broad swath over the entire Pacific. Easterly winds, trades, very strong in the East Pacific, the Central Pacific, and we'll say moderate over the Kelvin wave generation area. But it's not the absolute winds. It's the difference from normal for this time of year because winds tend to blow, pretty strong in the summer, not so strong in the fall. So we're looking at the arrows here. Still these east winds, still a bit stronger than normal out of the east, just looking at the arrows. And the same thing over the Central Pacific. And then over the Kelvin wave generation area, weak to moderately above normal out of the east. So that's no sign of the active phase of the MJO. We'd want to see these arrows coming out of the west, but we're not seeing that. Let's go take a look at the forecast for the next week. Now this is a bit of an intimidating chart if you haven't seen it before, but it's the whole planet on one chart, and it's showing the zonal wind anomalies, fancy words for what the winds are doing about 4,200 feet up in the air. If they're blue, purple, they're stronger than normal out of the east, which would be going that way, which would be enhanced trades. If they're yellows, reds, westerly anomalies, the yellow and reds are associated with the active phase of the MJO, the blues, the inactive phase. All right, and the Kelvin wave generation area starts in the far west Pacific, 135 east, right there. And the Pacific ends over here at Ecuador, on the equator only. About 80 west, but the Kelvin wave generation area where we're really interested from here to about right here. So you just literally go down the chart in the middle of the chart between these two areas here. You look, and we see in August, all easterly anomalies, inactive phase of the MJO, and what's supposed to happen for the next week, next 7 days? Well, it looks like those east anomalies are only forecast to get stronger in what we call very strong status. And California is about 120 west, so filling the entire Pacific to a point south of California, and then weaker from there into Ecuador. But again, it's the Kelvin wave generation area from here to here that really matters in terms of the jet stream and the supporting potential for storm development. So basically, the storm machine to be shut down this week. Now, does that really mean that you aren't going to get any storms? No, we're talking probabilities. That when you see this, yeah, the odds of getting a big, powerful storm are pretty low. That doesn't preclude the fact that there might be storms, that they might generate surf, etc., etc. But the odds are not in favor of that. All right, let's go out 2 weeks. Now, different flavor of data. The MJO, you can look at it from a bunch of different ways. You can look at the east-west component of the wind. You can look at cloud cover. All these sort of tell you whether low pressure is building over the Kelvin wave generation area. Okay, so here's South America, Central America there. Where we go? New Guinea there, Philippines there. So the equator, EQ, right across the middle of the chart. Kelvin wave generation area starts here, far west Pacific, and goes to right about the date line. So you just draw a box in your mind right in there. Okay, and so we see, and we're looking for blues. This is outgoing long wave radiation, fancy words for cloud cover, right? Blues are negative anomalies. That means less sunlight bouncing off the ocean surface. So really a dead neutral pattern today, 5 days from now, 10 days from now, and 15 days from today. So no active MJO forecast, but the inactive phase of the MJO, the reds and yellows, aren't forecast either. That per the statistic model, dynamic model, surprise, surprise, they're in sync. They're both saying the same thing. Basically, no MJO setup. But that's kind of a head scratcher because the previous chart said nuking east trades. So what's that mean? Well, if the MJO isn't doing something, then there must be some other process that's in effect. And our suspicion is this is the entrenchment of La Nina building, and it sort of takes over. You know, the MJO doesn't play a part as much. It's just this macro level La Nina pattern takes over. Same thing happens during El Nino. El Nino takes over, and you don't see the active phase of the MJO anymore, but you just see nonstop westerly anomalies and precipitation. We'll dig in a little deeper here. Okay, this is again the same model statistic, dynamic over here. Phase diagram charts. There's a little bit more detailed view. So what do we look at that circle there? Assume you're looking down on the North Pole. Okay, that is the circle, the North Pole. And the MJO travels around the equator outside of that, you know, sort of down the face of the globe, from west to east, from the Indian Ocean over the Maritime Continent, over the West Pacific, East Pacific, on the equator, Gulf of Mexico, and then across the Atlantic, over North Africa, back to the Indian Ocean. Round and round. The MJO goes the whole way around the planet. So does the inactive phase. So wherever the active phase is, the inactive phase is on the other side of the planet. The heavy dot right there, that's where the active phase is right now. So somewhere in the far east Indian Ocean, west Maritime Continent, near Bali, let's say. And if the dot is inside this circle, it's very weak active phase. And these are three different forecast track projections, basically moving to somewhere in the West Pacific and exceedingly weak. That per the statistic model. Dynamic model saying the same thing. Active phase ending up in the far West Pacific 2 weeks from now and non-existent. Upper level model. Okay, so this is probability for precipitation, yellows and oranges. Lack of precipitation, greens. In favor of precipitation, the lack of precipitation, of course, associates with the inactive phase of the MJO. So there's South America, Central America, 0 is the equator, and then there's New Guinea, dateline somewhere right around there. So Kelvin wave generation area right in here. The yellows suggest no precipitation, inactive phase of the MJO, inactive phase moving across the Pacific into Central America, we'll say early October. At that time, and very weak, and it's not very coherent picture, and then an even weaker version of the active phase to follow that, we'll say late September, cross the Pacific and into Central America by towards the end of October, and then another weak inactive phase after that. All right, let's keep digging. The CFS model, all right, same deal, whole planet on one chart, Kelvin wave generations, area starts right there, goes to about right there. Just looking down through here, we see this dotted purple contour, low pass filter. Okay, what's that mean? That's sort of high pressure, low pressure bias. The dotted is the high pressure bias, another signal of La Nina. And if you don't believe that, then you look and you see here, this is for the next month. There's this patch of nuking east winds right in the center of the Kelvin wave generation area for the next week. It fades out, and then theoretically, the last 2 weeks of the model run, late September and early to mid-October, same deal happening, just no hope for westerly anomalies. This was the last Kelvin wave we saw back in August, or not Kelvin wave, active phase of the MJO. Westerly anomalies, and nary a sign of that for the next month to come, and there hasn't been anything for the past 2 weeks. So again, more indications of La Nina. And then moving further out, 3 months out, all right, CFS model again, 3-month model. The forecast is up, past performance is down. Just looking in the past since May, you see the MJO has been very weak. You know, single or maybe double contour events. Other than right here, the current inactive phase, or past the peak of right now, is stronger. 3 contour lines, but then you see the solid contour, active phase, moving into the Kelvin wave generation area, which is right there to about right there. So right up the center of the chart. Weak active phase forecast, well, what is that, September 21st through about September 29th, like a week long. That's not even an active phase. It's just a sort of a dusting, a spice, if you will. And then it fades, but then comes back in earnest. And theoretically, and this has been on the chart for a while now, As we get into early, first week October, pretty good, healthy, active phase of the MJO is forecast, continuing in the Kelvin wave generation area the whole month of November. So, say mid-October to pretty much late into November, if that were happening. Westerly anomalies fairly strong, and building not coherent, not solid the whole way through the Kelvin wave generation area. You notice these easterly anomalies just digging in hard. This is that same easterly anomaly event we've seen on the other charts for all of October into November, and even holding, but again, not in the Kelvin wave generation area, but just this sense that strong high pressure probably over the north of Hawaii and the Gulf of Alaska sort of thing. That's not good for precipitation, or if there is precipitation, it'll come down very much north down the coast instead of like an atmospheric river type event. And then inactive phase of the MJO building as we get late November into early December. So no real obvious hope there. We'll overlay the low pass filter here. No surprise, nothing changed from last week. Dotted contour here is the high pressure bias over the date line. It's been here since June. Again, a La Nina signal. Forecast to build to two contour lines today, holding for the foreseeable future. The low pressure bias, this solid contour, set up in the Indian Ocean, building in coverage. Now, the one little hope is it will grow in coverage enough to maybe get a toe in the door in the West Pacific and sort of nudge the high pressure bias out. So maybe we'll get storms like pushing off Japan and Kamchatka in that area, and they'll make some progress to maybe the date line or so, and then they get shunted off to the north. And this is typically what happens, especially in Northern California. You get these sort of offshore wind groom conditions for days at a time, kind of cold wind blowing out of the Great Basin. But you get these 4 or 5 foot at 17-second period swells coming from across the date line. That does really well at some select beach breaks and kind of, from a pretty north angle. And you can get some good, fun, decent surf in that sort of situation. Nothing huge and crushing, but there can be surf. Less on the life-threatening side. Good in northern central California, but for Southern California, the issue is too north of an angle, really hard to get around Point Conception and get through all the Channel Islands and everything. You really need a storm that falls far to the south to get that preferred 280, 290 degree angle to get in well through the Channel Islands. So travel is probably going to be essential this winter if you're down in Southern California. All right, enough MJO discussion. Let's talk now about La Nina or El Nino. And the first piece or parts of evidence that we start looking for is the profile of temperatures down in the ocean, not at the ocean surface, but deep in the ocean's core. West Pacific here, East Pacific here. These are the anchor lines on the TAO buoys, that series of buoys strung across the equator used for monitoring El Nino, La Nina. This is exactly what they're meant for. The X's are the sensors on the anchors. You take that data, use a model to fill in the gaps, and you get a profile of what the temperatures are doing. This is in centigrade. You see the 29 degree isotherm in the far West Pacific, 28 degree isotherm at about 173 west. That's about where it's been. You want to see these warm waters pushing off to the east and making good inroads to the east to get you in a El Nino situation. And they're also sort of balled up here in the west. That suggests La Nina. That suggests stronger than normal trades causing upwelling in the east and pushing whatever warm water there is there off to the west. So I don't have to go through all this, but you see the 24 degree isotherms at 134 west. That's where it was last week, and cooler than normal water it looks like here. Let's look at the anomalies, differences from normal for this time of year. The picture is very stark and very plain. Warm water isolated 1 degree above normal, that's centigrade, so about 1 point multiplied times 1.8. Little finger of warm water making it, where's the date line? Well, 180 west there. Yeah, so making it to about 160, a point south of Hawaii, and that's it. Whole eastern Pacific, negative anomalies, -2, might even be -3 degrees, filling the entire East Pacific Ocean. And then you also get a sense that there's a channel of cool water filtering in underneath. It's from about 150 meters down. That's what you're really interested in. But if you have nuking winds here, you're going to get upwelling. Cold water in depth gets sucked up to the surface, and you see it's actually erupting on the surface the whole way from 160 west and east to there into, well, as far as this goes, what is that, 90? So that's a little bit west of the Galapagos. The high-res model, here we go, down here. You see it even more starkly. This goes to 80 west, so that's about where the Ecuador is. From Ecuador the whole way out to the date line, below normal temperatures, 1, 2, 3, 4, 5, 6, we'll say. 1, 2, 3, 4, 5, 6. 4 to 5 degree below normal temperatures here. That's the result of just nonstop nuking above average trades for months now. Classic La Nina kind of symptom here. The ocean is suggesting it. The atmosphere is manifesting it in terms of strong winds, and the colder the water gets, the more high pressure builds. The more high pressure that builds in the atmosphere, the stronger the east winds go, and it just starts. The ocean reinforces the atmosphere reinforces the ocean. What happens is you get whatever warm water there is, it just starts building here in the west and building up, maybe for 2 years even, and then at some point it all just collapses. The warm water starts rushing east, and you go from like a La Nina-dominated pattern to an El Nino-dominated pattern. We do not believe that is happening anywhere in the near future because we've just really started getting into this La Nina thing in earnest this year. Sea surface height anomalies, basically telling you the same picture. Rather than temperatures, this is the ocean higher or lower than normal? JSON 3 data, strip out the waves, the wind waves, the tides. You see there's a divot on the ocean surface 10 to 15 centimeters. You almost get the sense there's literally a wave here like a bulldozer. We know that this is South America here. There's the Galapagos, Ecuador there, Central America, and there's New Guinea. Dateline there, the equator here. The trades are just nuking here. You can see literally a front of cold water just sweeping, pushing off all warm water above normal anomalies, pushed off to the west here. Classic La Nina type pattern exhibited in this image. And then we can see all this over time here, past year, back in October, September. Warmer than normal temperatures, the oranges and yellow pushing from west to east. That was during sort of like a last year, weak, barely El Nino. Kelvin wave number 1, or there's probably number 5, number 6, and number 7 here. And then back in this year, in April, the first signs of this cool water regime building, trades building. It took a break in July. 4th of July, we had one big swell, right? And it was solid. And then boom, right back into a hole. Yeah, we've had some surf, but it's been generally small surf. Back into the cool upwelling phase, nuking trades again, and we expect this to continue building for the next couple of months, more than likely. Upper ocean heat anomalies tells the exact same picture. This is upper 300 meters of the ocean from the date line over to just about near the Galapagos. You can see last year, warmer than normal temperatures. What's that? 0.8, 0.6 degrees centigrade. Warm water, and then you hit April, and it's like someone just flipped a switch. Boom, the trades started nuking. Temperatures dropped off over the whole eastern Pacific and are continuing to do that till today. So that's the subsurface temperature data. Clearly, that indicates a cool regime. We go look at surface temperatures. No surprise, we saw this last week, but if anything, you can see the blues, cool. There's sea surface temperature anomalies differences from this time of for this time of the year. You see much cooler temperatures. Ecuador's right there, the Galapagos right there. This is the Nino 1.2 region, the official El Nino monitoring region. Nino 3.4 starts out at 120 west, so from here 5 degrees north and south of the equator out to 170 west, so right in there. No hope for any warm temperatures, all cold, and notice markedly colder here in this region, right from, we'll say, the Galapagos out to about 1 135 or something. Trades are blowing very hard in here, and it's not just a day or two of trades. This is weeks of trades blowing. Past 7-day trend. So I think last week right in here there was a lot of blue, and today we're seeing warming. The reds saying, okay, maybe the trades are backing off a little bit right now. Reds temperatures warming. That doesn't mean it's warm. It just means compared to what it's been, sea surface temperatures are warming somewhat in this area. So sort of an ebb. There's the ebb, the ebb and flow of La Nina and the MJO sort of makes it so the trades pulse for a couple of, 4 or 5 days. They back off a little bit. Temperatures rise a little, and then they start nuking again. But the balance has clearly been towards a cooling trend, or a cooling trend. You can see that in this image. I mean, it's just the classic La Nina signature, cool water temperatures. Now the question is, how long will that last? We don't know. Right now, it's just fully getting, the typical cycle is it gets going good around this time of the year and goes till about Thanksgiving or early December. It peaks out then, and then it starts fading. The issue is by that time the global atmospheric circulation has changed. This has been going on since April, and it takes equally as long for the upper atmosphere, the jet stream level winds, to sort of settle down and go back into a normal pattern. So even if this died, we'll say right now, our winter is pretty much gone. We wouldn't see a change until probably 5 months after this died. So September to October, November, December, January, February. Yeah, like March, we'd say, hey, it's returning to normal. But the reality is this is probably going to keep building for months. So more of the same is expected. Sea surface temperature trend in the Nina 1.2 region today. Temperatures minus 1.765 degrees below normal. So that's like 3 degrees below normal, roughly. And it's been steady for more or less months. It can't really get any colder. Trades have just been nuking hard. I mean, yes, it could get colder, but this is cold enough. You don't need anything more. And even in the official El Nino monitoring region, the Nino 3.4 region, you can see it took a while to wake up and have the cold water start working its way into this region since it's further west. But you can see temperatures on a steady downward trend today. 0.738 below normal. If you're at half a degree below normal, so right about here for, 5 consecutive 3 months period. So we entered the start of what I'd call La Nina. The beginning of the window was probably mid-August or so, mid to early August. We got a ways to go, but it seems pretty obvious where we're headed. So we've talked the subsurface temperature, ocean temperature profile for La Nina. We've talked the surface temperature profile. What's going on in the atmosphere above is the coupling of the atmosphere and the ocean that really form La Nina and El Nino. So Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When you have higher than normal pressure over Tahiti, the index goes positive. And again, it's high pressure in the Pacific that is the hallmark of La Nina. The index today is 3.03. Not so bad. Okay, but you go back in time, we're just going back a month, and you can see we've been 20, 22, 23, 26. So yeah, there's been some negative little windows, but by and large positive. Not so bad today. 30-day average, it sort of averages all this out. The past 30 day, we're at 9.20. When you're up and around 12, that's the sign of La Nina. We were up at 10 there. We were lower a month ago. The trend steadily building. The 90-day average, so this is a lagging indicator. It takes 90 days worth of data. We were at like negative at the end of the month, turning dead neutral. And now, September 13th, we're at plus 3.84. And the expectation, this is only going up from here. Here's a 30-day average graphed out. Here's where we are today. This says about 8, value of 8. But you can see the trend has been steadily upward since our low of, we'll say, last summer and fall down. We got down right around the end of September to minus 16. These are the active phases of the MJO, the inactive phase. You see the upward trend. This is like a long-running active phase of the MJO. had a good active phase right here, but overall, just the inactive phases are taking control, pushing almost to 10. So it's telling the same picture, moving towards La Nina. The official forecast from the CFS version 2 model for sea surface temperatures for the Nino 3.4 region. This is all confirmed data. We're down in the negative, let's say 0.6 or 0.7 as of today. Heading steadily downward from here to minus 1.6 degrees in the Nino 3.4 region. We're at what? Minus 0.7 now. So twice as far down in a hole. I think that's probably pretty overstated, but still showing this thing peaking out around end of November, early December, something like that, Thanksgiving. The good news is a steady upward trend after that, moving into neutral as we get into maybe May of next year. So this year is the year that we have to pay the price, pay our dues, so that we can have good surf, hopefully, after that. CFS sea surface temperature forecast. Doesn't take a genius to look here. There's South America. See the blue, the cold water. I mean, this is what? October, November, December. We'll just pick some. We'll pick December. Here you go. Big, cool, cold water. Yeah, warm water on either side, but it's right on the equator that really makes the difference in regards to wherever this is. High pressure is north and south of this, so this pretty much says high pressure in the Gulf of Alaska, high pressure off of South America, dry pattern, or if there is storms, they're up and over and falling down, driven by this lack of snow, blocking high pressure, storms in the West Pacific, generating swell, then getting pushed up into Alaska. I mean, that's a very, just a rough approximate guess of what's going to happen. But, all this confirms basically what we've been saying. So the good news is, right now, there's swell radiating to the north. Let's see, it's a storm pushed under New Zealand Friday, Saturday, so not next weekend, but just after that, maybe relative to California, and maybe for the weekend for Hawaii, some swell. And then for, very small weak southern hemi swells after that. Nothing from the North Pacific, but wind swells we get into next weekend, exposed breaks in North and Central California. No, nothing really for Hawaii from the north. Maybe some wind swell with luck. So we'll keep our eyes on that. Clearly, the long-term pattern is towards La Nina. I mean, we're not going to sugarcoat it, but we're not going to say doom and gloom. This doesn't look like it's going to be a major significant La Nina, not like what you get after typically you get a large El Nino and then you get a equal and opposite reaction right after that in terms of a large La Nina. This looks sort of a more like garden variety standard La Nina, and it really got started last year. We're hoping that this year we'll pay the price, and then as we get into the following year, it'll be back to kind of business as usual with a standard pattern. At least that's our guess as of right now. All right, so that's kind of it. If you enjoyed the video, give us a thumbs up. We appreciate it. We work hard to do this, but it's fun. We enjoy doing it for you. If you haven't subscribed, please subscribe. Hit the subscribe button down there. You get an email. If you don't do that, that's okay. Go to stormsurf.com. All the data you've seen is present on the site. You can poke around there, and we post links to the video when we post them, typically Sunday nights about this time. And that's pretty much it. So be safe. Have fun. Go get some waves when there are waves. Make the most of it. And then go do work. Take care of business. Whatever you got to do. This will be the winter to do it, I suspect. When there are waves, clear the decks and go surfing. But when there aren't waves, go be productive. Do something fun. There are other things in life, if you can believe it. All right, so that's it for this week. We'll see you again next week. Same time, same channel. Thanks for watching.